part 2, sorry.
Yeah. So the gaseous vapors are pulled through the system into the condenser where they're recondensed and cooled and turned into ice. It's the temperature of the condenser and the pressure of the system that limits the solvents that we can use on the lyophilizer. So water, acetonitrile freezes at -40, water freezes at 0, our condenser is -84, so those are compatible solvents. Methanol freezes at like -105 or something like that. So our condenser doesn't have the capability to refreeze methanol, so methanol can't go on our lyophilizer. If you have questions about other solvents, you can ask.
Wait, sorry, I have a question.
Yeah.
Why does it need to refreeze? Like, what part of it is getting refrozen?
So if it doesn't freeze at the condenser, then the vapors will travel into the pump.
Right.
And that just limits the lifetime of the pump.
So you want it to freeze and stay here?
Yeah. Because basically there's a vacuum pump in there that's pulling everything down to 0.14 and also pulling the vapors into this space. And if there's nothing to condense them in this space, they'll just travel into the pump. And organic solvents are bad for pump oil, just all the mechanisms of the pump.
But the temperature of the sample is room temperature.
The temperature of the sample is coming to room temperature over time. Yeah. Okay. Then we can talk about how to actually put samples on. So you'll have a sample, say from the HPLC, that you want to lyophilize. Our lyophilizer is not the most powerful lyophilizer in the world. It's a little bit old, so even though it should be able to remove 100% acetonitrile, it can't practically. So the rule of thumb is that our sample should be 50% or more water. So if you have a sample that's 75% acetonitrile, dilute it with water to at least 50%. Next, you have to freeze your sample. So the way we do this is typically with liquid nitrogen. You can also freeze it in the -80. So you freeze your sample in a bath of liquid nitrogen. Another rule of thumb that we use is 1 minute in the liquid nitrogen per mil of solvent that you want to lyophilize. And then so you leave it in the liquid nitrogen for a given period of time. You bring it over frozen, and I should have brought a bucket as an example. Then you can attach your sample to the system. Do you think this one's done, Trey?
It's still cold.
Still cold, yeah.
Maybe not. Yeah.
Thanks.
How's everyone doing?
Oh, one important thing that we learned about this feedback. If your sample isn't open, then it won't lyophilize because it won't be exposed to the vacuum. So you can see all these samples on the lyophilizer are just covered with Kim wipes, which are porous membranes basically that allow the pressure in the tube to equal the pressure on the system. So make sure your sample is actually open to be exposed to the vacuum.
Do you want to tell your parafilm trick?
Yeah. So I don't like to just cover the sample with a Kim wipe because in case there's any melting that happens, your sample might spill out and then just get absorbed by the Kim wipe and then you'll lose it all.
It has happened to me.
It happens frequently. So what I do is I parafilm the top of all of my samples and then I poke holes in them with a needle and then cover that with a Kim wipe to prevent any issues if something melts by accident. So your sample is frozen, you brought it to the lyophilizer, it's thoroughly frozen in liquid nitrogen. How I do this is you find a inlet to the condenser that is functional. I'll just use this one. This one doesn't work actually, but just for presentation. And I'll attach the neck of the lyophilizer bucket onto the system, like this. The next step is that you're gonna have to put your sample on the system and expose it to vacuum. In doing so, you introduce atmospheric pressure to the entire system. And if you have a really powerful lyophilizer, that's fine. But our lyophilizer is not so powerful, so it's good practice to put everybody else's samples under static vacuum when you put your sample onto the lyophilizer. So the way that we do that is we adjust the knobs. You'll see now that the notch for all of these samples is pointing down towards the neck. That means that they're all under active vacuum. To turn them under static vacuum, you rotate the knob just 90 degrees so that the notch is facing perpendicular to the neck.
And all of these angles that Harrison is talking about is to this neck. So when it's down, he just means that it's like down from like here. Actually, this is not fully on. I turned it on. Okay. So then, yeah, now it's like down. So it doesn't mean down to the ground.
Yeah. Down relative to the neck. So I'll turn all of these under static vacuum. And then I'll put my sample from the liquid nitrogen into this flask. Quickly put the flask onto the instrument. It kind of suctions in, and then turn the valve to be fully parallel with the neck. So that introduces vacuum to this sample. You'll notice from the front of the lyophilizer, when I do that, the pressure reading is now high because I've introduced atmospheric pressure to the entire system. So what the lyophilizer is doing now is actively pumping down this flask to be 0.14 millibar. And you can see it's doing that, starting to go down, 5, 4. And it should go quickly, but it will only go as fast as it takes.
Oh, also related, the -80 is right here, so it's actually really easy to put your cold boxes on this. This shield does crack, it has before. So then when you take out boxes from there, try not to keep it on this like glass thing because it compromises the integrity of the glass.
Right.
And if you see condensation over here, like try to wipe it down. This is actually why we keep the paper towels over here. So whenever you see condensation over here, if you wipe it, it'll be helpful to keep the glass going longer.
Just gonna turn the flask off, just so.
So that is faster?
Yeah. Because I think it's because that neck doesn't work.
Oh, yeah.
So remember now, everybody's samples are under static vacuum, but they're also still experiencing the ambient temperature of the room. So they actively could melt at this point. So you want to be kind of vigilant here. You don't want to just like leave and wait for your sample to reach 0.14 and then not come back for a little while, because everyone else's samples will start to melt. So you want to watch and make sure that the vacuum still reaches adequate pressure, like pretty consistently. You want to check so that you're here to return everybody's samples back to the system before they melt. So typically what I do is I wait until our vacuum reaches 0.3 and then I reintroduce vacuum to all the samples. So it's 0.31. So remember, they're all under static vacuum because the notch is perpendicular to the neck. I'm going to put them back under vacuum by just rotating them back so the notch faces down towards the neck. And I do that for all the samples. So now everybody's samples are all under vacuum again. And this should continue to pump down all the way to 0.14, which is its set point, 0.14, 0.16. So now you wait until your sample lyophilizes all the way. There's no good way to know if it's completely dry. Rules of thumb, typically 10 mils can lyophilize overnight. It depends a little bit on the solvent composition. I usually give my samples 2 days to be sure that they're completely dry. One thing you can try and do is feel the outside of the flask. And if it feels cold to the touch, there's likely still ice in there, so it probably is not done lyophilizing. If it feels room temperature, it's probably ready. And yeah, we've reached pressure. So now, let's say it's 2 days later, your sample is completely dry, you're ready to take it off. So you return to your sample. You don't need to worry about anybody else's samples, just your own. And what I do is I put my finger over this hole that's kind of on the outside of the necks. And that's the spot where atmospheric pressure is reintroduced. So air rushes back into your sample, and you turn this knob such that the notch faces out towards that hole. And so now my finger, the glove of my finger, is feeling the vacuum of the flask. I can feel it. It's like kind of being pulled in. And what I do is I hold the bottom of the flask. I don't want it to like fly off. It probably won't, but just in case. And I really slowly introduce air into the flask. That's because lyophilizers, like notoriously, give really fluffy powders. So if you just let the air rush into the flask, it will blow your powder everywhere around. It's hard to recover. So now this flask is at atmospheric pressure. You can just pull it off of the instrument and get your sample. And yeah, during the process of taking things off, you haven't touched anybody else's samples, and they haven't been exposed to any atmospheric pressure, so they're fine. You can just leave, and then that's it.
Thank you, Harrison.
Yeah.